All right, we're going to get started. Make yourself comfortable. So welcome to our talk, Designing Metro-Style Apps that are Touch Optimized. We're really excited to be talking about touch to you. We've been working on this for a while. I hope you all are having a great time here. I hope you had a nice lunch. We did. We were actually scavenging the halls here because we're really into free food. JK and I are always roaming the halls at Microsoft, also looking for free food. So we're having the time of our lives here. But let's get going and start talking about touch. My name is Kai Hofmeester. I am the user experience lead in Windows, and I've been working on touch for several years in Windows. And before that, I was leading the design team at Surface. And at Surface, we had the opportunity to build a great touch experience from the ground up.
And my name is Jan Christian Markiewicz. I'm a program manager on the Windows Core Experiences team. And I've been working on natural input for Windows for the last 5 years. Actually started on the tablet PC team, and then later worked on pen and touch input in Win 7. And in Windows 8, I worked with Kai and his great team on touch. And like Kai just said, I also really like free food. And free food was actually the first time I got introduced to touch devices. And this was about 10 years ago at my university back in Norway, where Microsoft came to campus. And they wanted to show off some new, cool technology, and they also had some opportunities for recruiting and all that stuff. But of course, I went there for the free food. But when I got there, I was really amazed by something. And that's what they showed me, and that was a Pocket PC device. This was so cool. This was basically a little computer with a resistive touchscreen that I can put in my pocket. So I can walk around with a computer in my pocket. That's so cool. So then they announced that they had a competition where they would give 3 Pocket PCs to the best student apps. So of course, first thing I did was get a hold of a C# book, learn how to code for C#, and I made my first .NET app. I submitted it, and actually won one of the devices. So sweet, got my touch device. Small part of the story, I guess, is that only 2 people sent in their app. Just a detail. Who else had a Pocket PC device here? Anyone else? Oh, a lot of people. It was a really cool device. But I think we all agreed that since then, touch has come a long way. But what we think is that touch still has a long way to go. And that's what we're going to be talking about today. We're going to talk about how we set out to reimagine touch for Windows 8. And you might be wondering, like, oh, why do you guys care so much about touch? But when you think about it, touch is really at the base of everything. It doesn't matter if our new user interface looks pretty if the interactions with the interface aren't right. And that's why we set out to really reimagine touch and design a touch-optimized experience.
And that's what we were working on at Surface as well. Because at Surface, we could start with a clean slate, or rather with a clean table, I think. We had the opportunity to do a lot of experimenting. We created different prototypes. We did different kinds of user research. And through that, we could find out what is a truly optimized touch experience. What is the best way for people to interact with the touch system? And I want to show you an example of one of those studies. Here you see a typical setup in our lab. So we invited, in this case, we invited 2 people in to interact with the Surface table that you see in the front. And on the right-hand side, just off screen, is the researcher. The researcher is just showing them a piece of paper which tells those 2 people what they have to do. So we want them to perform something. And in this case, what we were trying to learn is how can we differentiate between different gestures using different numbers of fingers. In this case, if you use 1 finger, you'd be scrolling the content. If you use 2 fingers, you would be moving the window. Sounds pretty simple, right? Or at least we thought it sounded pretty simple. But let's have a look at what these people actually do.
Okay, so maybe you put your hands hanging off of this, and you put your hands inside. So see how you put it inside the pane? Wait, this means I can breathe the pane. Or if I do it. But then you reach inside. Oh, so with 2 hands. There you go. There you go.
So obviously, we didn't wanted that you need 2 people to be able to scroll a piece of content. But like I said, we learned from our failures and we learned from our successes. So in this case, actually what I have to say is we're very grateful to people like this because they were always very persistent. These people actually kept trying and trying to figure out what we were trying to teach them, and we hadn't told them in the beginning. So what we learned from this is that you shouldn't use different numbers of fingers to differentiate between different gestures because it just makes the system much more complicated to use. So we did lots and lots of studies like this. And over time, we began to realize something important. And what we realized is that if users are interacting with the system, when they're touching the system, they're actually thinking with a mouse brain. And what we mean by that is they're still thinking as if they're using a mouse using the system. We knew that, for instance, because when they would be tapping on the screen, they would call it clicking. Well, by itself, that's not such a bad thing if users call tapping, clicking, whatever. But what's not so great about it is that it greatly limits our ability to use the rich touch interactions that we have, such as, for instance, pinch, if users think as if they're using a mouse. So what we needed to do is think about how can we change the way that they think about, how can we change the way they think about interacting. And to learn more about that, we took a step back and we looked at how the mouse works. So let me take a step back with you in history and look at that. As we all know, this is the first mouse ever invented. I love this picture. It was invented by Engelbart's team in 1968. And it's a really great invention. But what's interesting about it is that when it was invented, it didn't have a great way of using it because the mouse was still used with the command line interface. That's kind of strange. I kind of forgot about it because it's so logical that you use the mouse with the graphical user interface. But the graphical user interface was only introduced several years later in 1973 when the Alto computer was introduced. And this is the way that we know now how you interact with the mouse, right? You use windows, icons, menus, pointers, and that enables the great interaction that we have with the mouse.
So if you think about it, the graphical user interface is really the mouse language. When we see the graphical user interface on different computers, we know how to use the mouse because we recognize all those elements. So what we tried to do to better understand this, we actually broke it down into certain properties or components that build an input language. The first one is the properties of the input device itself. So when you look at the mouse, it's an indirect input device that has a cursor that's pixel perfect. And that's a great tool, right? But you really have to think about what that means for your design. And specifically, what does that mean for your interactions? And your interactions are really what you do and what they map to. So in the mouse case, double-clicking is great because you can hold your mouse still, and it's really easy to double-click to launch something. And the interaction for mouse is the things we learned that double-click means launching, while as using the scroll bar is used for scrolling. Another important part of an input language is the system feedback. And we're going to talk a little bit more about that later as well. But when you think about mouse has been developed for over 30 years. It has a lot of refinement, and there's a lot of things we kind of take for granted that's just there. So for example, I move my cursor around, and that's feedback that the system is listening and responding. If I hover over an object, it will give me some sort of hover feedback. And also have tooltips. And this is all system feedback that in our day-to-day use, we don't really notice, but it makes a big difference. And finally, how do I understand what language to use? Well, that's what the visual environment does. When I see a graphical user interface with windows, and there's menus, and there's a cursor, I automatically know how to use it, right? So what about touch then?
Well, touch has been around for a long time as well. This is an example of this. This is the Plato computer, which was launched in 1972. But the difference between touch and mouse is that the touch language hasn't developed as fast and as far as the mouse language has. In effect, what we think is that we're still using the graphical user interface to interact with touch. This language it doesn't have the gestures that we're using for touch are still incomplete. They're inconsistent. All right, let me give you an example. Let me give you an example of the properties. If I touch a screen with my finger, the part of the finger that touches the screen is that dark area that you see there on the finger. But what the system sees is only a single XY coordinate. So what can happen is I can be touching something on the screen, like a button or a window, but the system can actually be thinking that I'm touching right next to it. So the system thinks that I'm missing that item.
So that's actually a really good point and something that was really annoying to me. And I'll show you a quick example. So in the next picture here, I'll be, advance please, thanks. So in this picture on the left, you can see I'm clearly touching the play button, and I just want to play my music. But then when I lift, nothing happened. I was clearly touching it, nothing happened. And that's because the system just interprets the single XY coordinate, which happened to be just outside the button. So the system doesn't really understand touch. So that was the first thing we went out to solve with Windows 8. If we want to create a great touch-first experience, the system needs to understand the rich input of touch. So let me give you guys an example of how we can actually use that. So this is just my desktop. And what I'm running in the bottom right corner is actually a tool that shows me what the system understands, because that's really what matters when I'm interacting, right? And the system needs to understand my touches. So while as a traditional system would just use that middle little XY coordinate in the middle there to try to interpret my touch, for Windows 8, we collaborated with a lot of hardware partners to actually be able to get the rich contact surface data when I'm touching the screen, so we know what part, I call it the fleshy part of my finger, is touching the screen. So that way we can actually be smart and understand touch. So that the outer circle represents that. So what you're going to see me trying to do here is to resize the window. So my finger is physically touching the very edge of the screen, and you can see how we can be smart now and actually make the system understand touch so that I'm successful as opposed to failing. You can see that example here again. So that's great. So we did a lot of work on the input stack to actually make the system truly understand touch. And this is like the very basics of touch, and we really need to get that right. But there's also a lot of other things we need to understand about the touch interactions.
So there's other properties about touch that are really important, properties about people. And to learn more about that, what we did is we did a lot of field research. So we went into people's homes, and we looked at how they were interacting with their systems, in this case, with their tablets. And one of the things that we learned is what kind of postures do people use when they interact with them. And there's two postures that are really important. One of them is where they hold the tablet with their non-dominant hand, often with their left hand, and they will support it often either on their leg or on the table, as you can see in these pictures. And now they have their whole dominant hand, so often their right hand, available to interact with the system.
So one thing to realize with that, so you're holding with one hand and you have the whole second hand available. So that's very different on a tablet than what we're used to on our phone, right? So on my phone, typically one hand holding and one finger interacting. Whereas on the tablet, we have the richness of a whole hand here to do really rich interactions, zooming, panning, anywhere on the screen. That works really great.
So the second posture that we learned about that was important is where users hold the tablet with two hands and they interact with their thumbs. And in this case, they can be either sitting, but they can also be walking around or standing or even lying down. And what's interesting here is now people have their two thumbs available to interact with the system. So we wanted to learn more about what it means to have two thumbs available to interact. And what we did for that is we asked people to dip their fingers in finger paint. And then we took a piece of paper the size of a slate, and we asked them to draw with their fingers on that piece of paper to see which areas were comfortable to reach and which areas were not comfortable to reach. And in that case, we created many of these kind of pictures that show which areas are comfortable. We combined that with data from ergonomic data about lengths of fingers and the sizes of hands, and in that way we created these thumb heat maps. And now these thumb heat maps, they influenced how we created our designs. So for instance, when we worked on the thumb keyboard, that's a split keyboard, it influenced where we would put the keys and how we would organize them. But it also influenced how we created apps and which part of the apps should be interactive and how you should interact with those. So that's an example of how what we learned about postures influenced the different designs that we made. In addition to doing that field research, we also worked with ergonomists, and we learned a lot about the body and the capabilities of the body. And there's two things that I want to call out here. One of them is that even though our UI is created to interact in straight lines, like for instance, if you scroll, you interact in a straight line, our body is created to interact in circles. So if you look at my joints, they all make my hands move in circles. And to draw a straight line on the screen, for instance, to scroll a page, I have to use multiple joints at the same time to be able to create that straight line. And so that line will actually never be straight. It will always move up and down a little bit. But we don't want our UI to be moving up and down a little bit. So we have to account for sloppy gestures, as we call it. Another thing that we learned is that your body is good at certain things and not so good at other things. And one of those is your body is made to contract. So it's made to grab things, but it's not so good at extending your joints. So what we learned is that it's easy to slide down with your finger, for instance, but it's harder to slide up. In the same way, it's easy to pinch, but it's harder to stretch. So these kinds of things that we learned about ergonomics, they influence the kinds of touch interactions that we created.
So yeah, I think that's worth saying again. So by learning about the anatomy of the body, we can actually just look at that and figure out what a good gesture is. Like we know, for example, stretching out is not as easy, so we should rely more on pinching and use that in our design. So these are some of the basic properties of touch and how we can leverage those. But when we actually started looking at the interactions themselves and how we use them, there's two really important things I want to talk about. And the first one is how it's really important to make sure that content stays stuck to your finger. And that's what we call direct manipulation. So the easiest way to explain this is to show an example of what you should not do. So this is a little video of an app where I can do these gestures. I can flick, and it will switch between my photos and just do like, I'll do the action, the system will try to respond, and then it does a little animation and switches. So that's not direct manipulation. Direct manipulation, on the other hand, I'll have content be fully stuck to my finger. And as you'll notice in the video here, there's three really important things about direct manipulation. The first one is that there's immediate visual feedback. As soon as I move my finger, the content moves, and that makes me feel like I'm in control, and that makes me confident. The second thing is there's no hidden thresholds. So as in my previous example, it was really hard to perform the action, and it was also really hard to learn it in the first place. When you're using direct manipulation, because I get that visual feedback immediately, it's really easy to learn it, and it's really easy to do it again. It's so easy to use it. You guys have all probably used these kind of apps, right? And the final important thing about direct manipulation is that it's reversible. So what we mean by that is that because content is moving directly with my finger, I can actually change my mind, and I don't have to commit. So as I'm scrolling through my photos, I can actually kind of peek and look at what's there, and then I decided I actually don't want to move to the right, I want to move back, and I can reverse my gesture. So this is really important with touch, because when you're touching the screen, you're kind of already committing, but this way you can safely explore. You can try stuff, and if it's not what you like, you just push it back. So it's really important to have the visual feedback, the immediate visual feedback, not use weird invisible thresholds, so you need to have the visuals to really explain what's going on. And then finally, reversibility. The second interaction I want to talk a little bit about is time gestures. And none of us like to wait, right? And we've seen this before, this thing, unfortunately. So waiting is not great, especially if you want to have a fast and fluid interface. And as we were doing a lot of experiments, a lot of usability testing, there's a couple of things we noticed. Some of them are obvious. If you want to do commanding, it kind of sucks to have to be slow every time. So you have to press and hold, wait, something happens. And if that's the way you command, you have to be slow every time you command. And advanced users, they don't like to be slow. They want to get their stuff done. So that doesn't seem like a touch-optimized way of doing commanding. The other thing is, a lot of novice users, they'll be a little slower as they're using the system, maybe dwell their fingers. And the problem we saw a lot was that they'll accidentally do these time gestures. And this is particularly bad if you go into some special mode or you launch something accidentally, and then users will get confused. All they were doing was just like panning around slowly on the screen, trying to be a little careful, and we like spring up this surprise hidden UI. And that feels pretty bad. So that's why for commanding, we really want to avoid time gestures. That's not saying that time gestures are completely bad. We just need to think about what they're good for, and we want to use them for that instead.
So what we did is, like I said, we created lots and lots of prototypes, and we tried these prototypes with different people, and looked at what their behavior was, and we learned from that. And over time, we would string together these different prototypes into an end-to-end experience. So we had this prototype that would bring people from the start experience to different apps, and then we would see how they would react to that and learn from that. And over time, what we became aware of is that how our touch language was actually working and which things about it were good. And this is an example of something that we learned. So let's look at this video, and please listen closely to what the user has to say.
I had a very small learning curve. Once you know the touch, I like the fact that they're the same in every Woody application. But once you know how to operate email, this operates the same, selecting pictures operates the same, etc. I like the continuity of that.
So over time, when we started implementing the gestures more consistently across applications and across the system, users began saying these kinds of things. They talked about how they had to learn some of the new gestures, but then once they learned them, they could apply them in different places, and it became easy to use for them. And this built confidence for us that we were going in the right direction. So it was not only this research that kind of inspired our touch language. We also had the design principles that Sam Moreau presented in the talk just before us. And they also influenced the goals of the touch language. But I quickly want to go over those now, over the goals of the touch language right now. So first of all, the touch language has to be simple and consistent, because in that way it is, once users learn it, they can apply it across the system. Also, we want to use a limited gesture set so it becomes easy to learn. Then we want to use direct manipulation, and JK just explained why that's a great thing to use. We learned from the research on postures and anatomy that sliding directions are great for touch-first interactions. And we also learned that reversible interactions provide more confidence to the user because they can always get out of an interaction if they want to. And finally, because we wanted to make the system fast and fluid, we're trying to avoid modes, because modes will slow you down and they can cause errors. And we also want to limit the use of timed gestures for commanding. So all these things together, they inspired our touch language. And what we want to do now is kind of show you what that touch language actually looks like. And the basic part of that is, what are the actual gestures? Now, there's only 7 gestures that make up the touch language. But the gestures by themselves don't mean anything if you don't know what those gestures do. So this is actually what those touch interactions are. There's press and hold to learn. There's tap for a primary action, like launching an application, for instance, or navigating to another page. There's slide to drag, for instance, for scrolling. There's swipe to select, and we'll explain in a little bit what we mean by that. There's pinch and stretch to zoom. Then there's swipe from the edge to bring up app and system UI, and we'll talk about that a little bit also. And then finally, there's rotate. These are all the touch interactions that form the touch language. So once users know these, then they know how to use it everywhere. So it's not only these touch interactions that make up the touch language, there's also the behavior of the system. But this talk is kind of too short to dive into everything that the touch language is. So what we did is we picked 6 highlights that we feel really strongly about, and we want to show those to you right now. Some of those are touch interactions, and some of those are the behaviors of the system. So let's start with one of the touch interactions that we really care about, which is swipe to select. So what we needed to do for swipe to select is, as you know, tapping is for the primary command. So if I want to launch something or if I want to navigate somewhere. But now if I want to do something else than that, there's no way of doing that. So I need to be able to indicate to the system what I want to command on. I need to be able to highlight something or to select something. And as we just talked about, we didn't want to use timed gestures for that because it slows you down. We also didn't want to use a mode to go into some kind of selection mode because, again, it slows you down and it can cause errors. So we looked at what was the best gesture that was available for us. And based on our understanding of anatomy and how you use your body, the swipe gesture was the best gesture that was available to us for selecting. It's really easy because that's just a simple contraction of your finger muscles. So that's the gesture that we used for swipe to select. But JK, how would you show us how it actually works, this gesture?
I can do that. So let's go to the start screen. I bet you guys have all been playing with your slates. I have this special visual on here now so you guys can easily see what I'm doing. So as you all know, start screen is great. You can easily drag to pan around and look through your stuff. But now if you want to select, you just swipe down. Because we're using left and right to scroll the content, we can use a swipe down to select. So if I swipe again, it goes away. So a couple of important things I want to point out here. So first thing is, as soon as I select, the commands show up automatically at the bottom of the screen. So for example, if I want to make my tile smaller, all I have to do is tap the option. So now it's smaller. If I want to make it bigger, make it bigger. Make it smaller, make it bigger. There's no moding. There's no time gesture. It's super fast, and it's super fluid. So a couple of more details. So what we actually learned was we did a lot of work on this, and this definitely didn't work on the first try. We had to really get a lot of details right, and that's what I'll show now. So as I'm moving down, this actually uses direct manipulation. So you can see how the tile is following my finger as soon as I drag down. So that gives me strong visual feedback that I'm doing something different, and that's a good way of learning this. Another good way of learning what's going on, might be a little hard to see on the projector, but if you look in the top right corner, there's a little check mark. And I'm revealing this check mark, and it kind of entices me to keep pulling to see, oh, what's under there? And once I've revealed it, there's another visual hint with the selection rectangle to show me that I actually selected. So now I can lift to perform the selection. So this interaction is reversible as well. So it's reversible in the sense I can just do it again to undo it, but it's actually reversible in the interaction itself. So if I start dragging down now, and I just decide, actually, I don't want to do that, I just put it back. No harm done. It's safe. I can play around. Nothing bad happens. So that's a very quick overview of how swipe select works on the start screen. But what about my apps? So here's a newsreader app. And again, I can scroll by dragging left and right. And what I want to do now is, tapping would typically take me into an article. But what I want to do is I want to select a couple of these articles so I can read them in the magazine view. And to do that, I just quickly drag down, swipe down to select. As I selected, the app bar shows up again, and I have a magazine option in the bottom right corner, and I just select it, and I'm done. So again, really fast and really fluid. There's no moding, no waiting. Let's look at another app. Here you go. So that was all in a horizontal list, right? So I can pan left and right. I select by swiping up or down. But what about vertical lists? Well, here's a vertical list. It's pretty straightforward. If I want to select, I just go the opposite way of panning. So I just drag to the left, select, and the commands again show up automatically. And I can undo this by doing it again, just like that. And what we saw in our user studies was that we would actually just throw this into the test. We would have them do a bunch of horizontal scrolling panes and just throw in one random vertical one. And users immediately just got it. Like, of course, I'm panning up and down, so I swipe the opposite way. So let's go back to the start screen quickly. So another way this is really a touch-first interaction is that we're actually leveraging the full target size of the tile. So we could have really easily made selection by just showing little checkmark widgets on every tile, right? But then we would have a tiny little target on every tile. And as we talked about, touch is sloppy. So this way, we can actually leverage the whole tile size because it's leveraging the richness of touch by dragging down. So I can, no matter where I drag on the tile, it will select. So I don't have to be careful about targeting. I can actually target anywhere on the tile. So we also leverage the swipe interaction for drag and drop. So if I now really I really care about my stock app, so I want to make it the first thing in my list of apps, all I have to do is drag down. If I keep dragging, this item eventually will just come loose. And now I can just put it wherever I want to put it. So if I do this fast, you're not really going to notice any of that resistance there. It will just come out immediately. So I can pan, really quickly put the tile where I want it. So again, there's no moding, so it's fast, There's no press and hold, so it's fluid, right? But again, there's a lot of detail that went into getting this right. And I'll show you one of the things. So for example, as I start dragging down, and I hit the selection here, if I keep dragging, there's a little bit of resistance. And you can kind of see the tile is kind of slipping away a little bit. But if I keep pulling now, it will eventually come to my finger. So why is that important? Well, touch is sloppy. And we want selection to be really fast and fluid. So by having that little bit of a resistance there, you can be really sloppy with the way you select, and you're not going to get into the drag and drop state. So I can be really sloppy, do this quickly as I move around. So let's go back to our deck. Cool.
So JK showed how this is a great, how this touch interaction is really optimized for touch and how that works really well. It's fast to use. But you might wonder, well, okay, great new interaction. How can users learn and discover how this feature works? Well, like we said before, what we learned at Surface is that we can quickly teach users new interactions, and they can become comfortable with it also quickly. What we have to do is we have to use the right visuals and the right kinds of animations to teach them this. And what I want to do is I want to show you one example of one of the people that we worked with in the lab who is using one of the prototypes for selection. What's happening here is she's learned this gesture kind of by herself less than 5 minutes ago. And what the researcher has just asked her is, what do you think about this? What do you think about this touch interaction? Do you like it or not? And while she is thinking about it, she is interacting with the screen. So watch closely what she does. So this is after she's discovered the feature, she's discovered the swipe to select only 5 minutes ago. And you can see first she's a little bit tentative. She's trying it out on the right, she's trying it out on the left, and then she goes really fast and selects everything. And this is all while she's actually thinking about what to say about it. So these kinds of results gave us confidence that we could teach users new touch interactions and that they would become comfortable with them.
So let's just quickly recap some of the takeaways about swipe to select and what it means for your apps, right? So we showed how swipe is a touch-optimized way to provide selection, but also commanding. And this is really important. If you just show selection and not your commands, then you're not going to have the fast and fluid way of commanding. So as soon as the user selects, make sure you use the app bar to automatically show the commands. And when we designed the touch language, we actually did a lot of work to make sure it's built into the platform, because we don't want to just have these guidelines and principles and then tell you guys to do a lot of work. So you're going to see this going through our whole presentation, but we put the touch language in our controls. Makes a lot of sense, right? So the best way of enabling swipe to select and also drag and drop is to just use the list and grid view controls that the platform supports. And Paul Gasmarino is going to do a great talk to give an overview about all the controls actually in this room after us. So we definitely recommend that you check out that talk.
So let's talk about another gesture. This one is swipe from the edge. So we learned from the research that based on postures, that swiping from the edge is really easy to use, both if you use your non-dominant hand or your dominant hand, your right hand, or if you use your thumbs. And we decided to use this touch interaction. On the left and the right-hand side of the screen, we dedicated to the system. And the top and the bottom side of the screen, we dedicated to your app. And one thing to note about this is that, again, this can be a gesture that can be sloppy, because you swipe in from the edge, but it doesn't really matter how far you swipe in or how fast you do it. So that makes it a really fast and fluid touch interaction.
Cool. So let's do a quick demo on that as well. And I bet you guys have been playing with your slates with this as well. So what I'm going to do is, so on the right side we have, and the left side we have system controls. So let's first look at that. So if I swipe in from the right edge, I pull in the charms bar. And this is where we provide all the system-wide commands and interactions. So let's just go to the start screen. And if I now just launch an app, I can use the left edge of the screen to pull in an app. And I can either do that with my thumb really easily, or I can just use it with my dominant hand and pull it in. So again, notice how we're using direct manipulation. I'm pulling in this app, which happens to be my PowerPoint deck, and I have immediate visual feedback. I can see what's going on. There's no weird, like, if I swipe super fast from the edge, it works, but if I swipe slow, it doesn't work. It just works. And the other thing is I have reversibility. I'm in full control. I can look at this like, actually, I don't want to go back to my presentation. I want to show cool demos. So I just push it back, and it's gone. So that's using direct manipulation, again, throughout the system. So that's how the left and right edge works. But what about the top and bottom? Because that's what's most interesting to you guys, because that's what we give to the app. So this is the build app. And what we use the top and bottom edge for is to provide application commands. So if I now swipe from the bottom edge, I pull in the application commands. And the posture could either be using my thumb like this, or I can just as easily hold my slate and use my dominant hand for that. So a quick swipe shows the app bar. A quick swipe hides it again. Almost. Hide. So it's really important that we have a consistent way of showing these commands so that users don't have to go and look all the kinds of different ways, like guessing where are my commands. There's one consistent place to find your commands, and that's through the app bar. So let's use this feature to quickly go back to my deck. Cool. So what does this mean for your app? Well, it's pretty straightforward. Use the app bar edgy, the top and the bottom edge, to show your app bar. And that's going to make sure that people are confident using your app for commanding, because they know where to look. They don't have to go and try other stuff. If they're looking for more commands, they'll try to use the top and bottom edge. And if it's not there, they'll probably just assume it doesn't exist. We talked a lot about postures and the way people hold their device and how the two-handed grip is really important. So you have to think about that when you place your controls. And at the bottom here, some examples of how by left and right aligning your controls, you can make sure that you can actually reach them, right? You don't want to unnecessarily make people switch their posture when they're using your app.
So I said we were going to explain what we think time gestures are good for. And in this case, what we're using, the problem we're trying to solve here is something that we discovered when we looked at the mouse language. So when we looked at the mouse language, you can notice that you can hover with your mouse cursor over things, and that will provide more information. So it will highlight an item, it can provide a tooltip with more information, or it can even provide richer information. With touch, we don't have a system that does that. Either the system doesn't see anything, and you're not touching the screen at all, or you're touching the screen, but then you've already committed, because as soon as your finger is down, you're already launching an app or you're doing something. So we're missing the same functionality that the mouse provides in hover. And that's what we want. That's what we're using Hold to Learn for. So what in Windows 8, you can hold your finger down on an item, and it will provide more information to you. It can provide a tooltip, or it can provide richer information. And then if you don't want to activate that, you can just move your finger off, and you won't do anything. So it's not a dangerous thing to use. The other thing is, if you accidentally activate it, so if you put your finger down and this information appears, it doesn't stop you from doing anything else. So it doesn't put you in a mode. You can still scroll. You can still launch an application. So let's have a look at how that works.
Great. So we're back at the start screen. And in this case, I have this big green tile with a little B in the corner. And if I wasn't at the build conference, I might be wondering, what is that tile about? There's nothing really telling me what that tile is. So all I have to do is press and hold. And after a very short time, I get this tooltip. And the tooltip gives me more information. So in this case, it gives me the name of the app. You can also imagine if this is a button that just has a glyph, it would actually explain to me what this button does. So that's something that's pretty common on other touch devices where, like, you see this button, and the only way to really figure out what it does is to execute it. Well, that seems a little dangerous. So this way, you can provide information before you commit. So another important aspect that Kai touched on is that if I accidentally just hold too long now, we don't want to do weird stuff where you get into a mode where you feel stuck. So I can still just pan, and the tooltip just goes away. So I'm never stuck in the mode. I just hold. The tooltip gives me more info, and it's just a little bit of extra info there. And if I just pan, it goes away automatically. You can also use this for a little more rich information. So I'm going to go to the picker in this case. And if I have photos here, and I just want to differentiate a couple of photos because I'm not quite sure which one I want, I can just press and hold on that one as well, and it gives me this richer tooltip. So again, it's really for learning. It's just telling me a little bit more information. So you shouldn't design your app to require this, but if it's kind of an edge case where you sometimes need to learn a little more, that's fine.
So why do we think it's OK to use a time gesture for this, but we don't think it's OK to use for commanding? Well, in this case, if you want to learn something about an object, you hold your finger down, and you can see that information as long as your finger is down. So there's nothing bad that happens. You're not inhibiting or stopping anything. The other thing is, we don't think that the learning experience itself has to be fast and fluid. It's not something you will do over and over and over again. So one time you want to learn about something, you hold your finger down, you learn the title, or you get that extra information, and then you don't have to do it again. And that's why we think actually press and hold is a great gesture for learning.
Great. So very quick recap. By using hold to learn, you can actually enable exploration without requiring the user to commit. So you can give a little bit of feedback. So it's almost like the user is just dwelling for a bit because they're a little unsure about what this thing does. And that's a perfect time to tell them what this is. Just give them a little bit more information. And the easiest way to build this is to just use the tooltip control that's provided in the system.
So this is the last touch interaction that we want to talk about here, and then we'll talk about some of the other behaviors after that. And this one is zoom. The problem we set out here is, again, something that is provided in the mouse language, but not in the touch language. And in this case, it's about scrolling content. So a great way of scrolling content with touch is to use direct manipulation, as we just said, right? I could have a long page or a collection of items, and I just touch the content itself, and I can move it back and forth. It works really well. But what it doesn't enable me is to quickly jump to the end of the document, or jump to the end of that collection, for instance, or to get an overview of it. In the case of mouse, that is solved by the scroll bar. So using the scroll bar, you can quickly jump to the end of the document or to the middle of a document, and you can see roughly where you are. So what we decided to do is to use the zoom gesture for that. Now, we all know that if you pinch and stretch, you can optically zoom the content. So it just becomes literally bigger or smaller. And what we did is we created semantic zoom. So again, I can still pinch or stretch the content, but now it will change to a different view. So it will show me the same information, but it will show me a different view of that same information. And that enables me to quickly jump to the end or to the middle of that collection or that document. And it also helps me to get an overview of what was actually in that document. Now, that view that we're showing, it's up to you what that view actually is. So it depends on the app or wherever it is shown, what is the best way of showing that. And JK will show you some examples of what that could look like.
Cool. So I might be a little biased, but this is my favorite feature of Windows 8. So again, start screen. And you guys saw this in the keynote actually yesterday. So I can just scroll around by panning, and I can go all the way to the end, but that's kind of boring, right? It works, but what happens when I have 200 tiles on my start screen, right? I want to quickly get to the end. So all I have to do is pinch my fingers, and I get this overview of my content. And now I can really quickly just go ahead and zoom in to the end. So I can do this by pinching, or I can actually just tap. And this goes back to what we learned about ergonomy. It's really easy to pinch. It's not hard to stretch, but it's a little more work. So why don't we make it easy to pinch to zoom out, and then you just use a tap to zoom in. So it's really optimized for the way our body works. So like Kai said, it kind of feels like an optical zoom, but it's not. So there's a couple of things there. So do you see that swap? And what happens is that we're abstracting the content to be more useful. It doesn't make a lot of sense to show these tiles, if you see all the green tiles on the right, with all that text being tiny and super small. That's not very useful when you're zoomed out. So instead, we replace the visuals with something that makes the most sense. And that's really what we're looking forward to see what all you guys can do in your apps, because this completely depends on your app and your content. I'm going to show a couple other good examples of that. Again, just to talk about direct manipulation, this is reversible. I can start my pinch and decide, I don't want to do that, and I just reverse it, right?
Sorry, is it supposed to work on our...
Yeah, so that's a good comment. So You guys might be a little confused because you want to try this because it's the coolest feature of Windows 8. It's for the developer preview, we had to focus on really getting the tools right and everything. So this was kind of not the first priority. We have a slightly different build that has this enabled. So hold on for the next set of bits. Yep.
I'll show that.
That's exactly what I want to show you guys. Actually, and this actually works in your build. If you go to search for your apps, you have this nice overview of your apps, and it's all sorted by these columns with these text headers. So let's say I want to go to the task manager because that was a cool thing in our keynote, right? Again, I just pinch out to get an overview. And in this case, what the semantic view is really a good overview of the groups I have, which happens to be the letter headers. So now if I want to go to the task manager, I just tap on T, and I'm at the task manager. So as you notice in this case, it was really not an optical view. While the start screen kind of feels a little optical, this is completely different, right? And I can really quickly jump around. So that's another example you can try in the system. You can also use this in the picker, where you can zoom out and you can get an overview by date and also by alphabet. But let's look at how you can use this in your app. So this is a sample game review kind of app, and I have all these categories. I have action and so on, and I can pan around and find what I want. But now if I really quickly want to go to action again, I can just zoom out, and I get this nice overview, and I can find what I'm looking for. Just tap, and it zooms in. So it both gives me a quick way to navigate, but it also gives me a nice overview, because now it's kind of hard to see all the categories I have. Whereas if I just zoom out, I get a really nice view of the categories.
Let's show the conference app also, because that's another example.
That's true. That's a good example for you guys. The conference app also shows this. So if you're in the schedule, you can actually pinch. And again, this semantic view that makes sense here is not to show tiny text for all the sessions or anything. It's to give an overview of the time slots where there's talks. And then I just tap to zoom in to see what's going on. So if I want to see what's the next talk, I just go to Wednesday, 3:30, and it zooms right in, and I can see all the next talks. So actually here we have Paul's talk coming up after us, which is going to be a good one. There's also another example. So these are kind of examples of really big views. That's almost your full screen. But you don't have to use that for semantic zoom. You can actually have it in the smaller view of your app as well. So going back to this app, I have actually a vertical list. And it's not the full screen of my app either. But again, I can just pinch out, and I get a good representation of my content. So actually, if you look at this here, these are all files that are sorted by date. So I have today, I have yesterday, and so on, last week. So if I want to go to last month, just zoom out, tap on last month, and I'm there. So this is a truly touch-optimized way of jumping. So we don't need this indirect scroll bar. We have a great interaction with pinch, and I can pinch anywhere in my list. So I can be sloppy. I don't have to go and target the little UI control. I can just pinch anywhere in the list and quickly jump and get a good overview of my app.
So this is an interaction that we are really excited about, that we really like. And it's not only us. A lot of the people that we tested this with showed the same excitement. That is, after we got the feature just right. Because all of these features, the way we show them right now, they required a lot of tweaking, and this one is the same. But after the tweaking happened, we had some really enthusiastic reactions to this. And it's interesting to note that often when we're doing these tests with people and looking at their behavior, their whole team will be there watching those people without them knowing about it. They're just interacting with the researcher. And it's almost like watching a sports game or something, because if they're failing, everybody feels bad about it. And if they're succeeding, everybody's happy. And often we're edging them on to go, even though they can't hear us. So we just wanted to share like a tiny little snippet of video of what people react when they discover this feature. So this is what typically happens, like when they discover it, they think it's really cool. But that's like, okay, they think it's cool. they have to keep using it. And specifically with this, it relates, they already know the gesture. It's something that they, once they discover it, it's something that they expect to happen. So you will see that people will use it throughout the apps. And if it's not there, they will be a little bit frustrated. They will think like, oh, why can't I do this right here?
Yeah. It's really interesting to see the emotional connection we get with this. And I think it's really about the feeling of being in control. You just pinch and your content scrunches together. And it's just such a delightful experience.
So those are some of the touch interactions that we... Oh.
Yeah, let's quickly just summarize Semantic Zoom, because we talked a lot about a lot of things here. But the main thing about Semantic Zoom is that it's really reimagining the way you jump in lists. It's a touch-first way of jumping in lists and providing a great overview of your content. And when we tried this, we tried a lot of crazy stuff. Like we tried multiple levels of zoom. We tried to, if you zoom out, you get like extra navigation controls and weird stuff. And we learned that that doesn't work. We really had to pull it back to the basics, because this is really, think about it, it's really replacing the scroll bar. It's a touch-first way of using, getting the functionality of the scroll bar. It's all about jumping in the content and getting the overview. So we don't want it to be a crazy thing. It should be very simple. And that's how it resonates across apps as well. So it should always be one level of zoom. You zoom out, and then you guys decide what's the best representation of my content in this view, and then you zoom in. And that's all it should be. And then, as you saw in the start demo, once you're zoomed out, because your context has changed, you can make some slight alterations. For example, when I'm zoomed out, I move a whole group as opposed to moving a single tile on the start screen. Again, as with most of the stuff we talk about, this is built into the platform. So there's a semantic zoom control that makes this transition really easy to build. It will do the right animation for you. It will make sure that the gesture is listened to correctly and that it's reversible. So again, just use our control. It's really easy to add it to your app.
So those were some of the interactions that are new in our touch language and that we are excited about and that we think you should use in your apps. But there's some other things I talked about before. There's some other behaviors that make up the touch language. And there's two that we want to talk about right now. One of them is the visual feedback that the system provides when you touch. And a lot of systems that are out there right now, when you touch them, there's very limited feedback that they provide, which is actually very different from mouse, because with mouse you get a lot of visual feedback. And I actually think that's kind of rude that there's not a lot of feedback, because it's almost like I would be talking to JK, and while I'm talking to him, he just turns his back to me, and in no way does he show that he understands what I hear or that he's listening to me. Only when I say certain keywords like, hello, JK,
hello,
is when he will react. And this is what I think what the typical touch system works like, right? It doesn't do anything or show anything that it heard me until I do the right thing.
It's just not very polite, right?
It is not very polite. And things that happen are like a few months ago, I was in an airplane where they had those little screens on the back of the seats that you can touch, the touch screens. But what they did with that system is that every time some announcement would be made over the PA system, they would turn off the interactivity of that system. So the person who was behind me, who was watching a movie or playing a game, I guess he was playing a game, every time the announcer would say something, the system wouldn't react anymore while he was touching it. Well, what do you do when the system doesn't react anymore? Well, you touch harder. So every time there would be an announcement, my head would be bopping up and down against my seat because the person behind me would be kind of jabbing on the screen. So that's just an example of what happens if you're not polite, right? If you don't respond to your user. So let's look at how we solve that problem.
So before I do that, let me just turn off these presentation visuals that are a little over the top on purpose so you guys can see what I do. And this is actually the kind of visuals you'll see when you're using the system, like when you guys are using your slate. So again, start screen, great. When I press down on the tile, like the stock tile in the corner, I get immediate feedback and response. The tile gets pushed down, so I can see it's reacting to my touch. If I start panning, you can actually see the tile pop up. So it gives me clear feedback that that tile's not going to activate anymore. So that way I know what's going on. And similarly, when I drag here, because the content actually moves, that's the feedback that the system is listening. So that's the kind of feedback that's pretty common where the control that's interactable actually gives you feedback. But what about touch things that aren't interactable? Because there's a lot of things like that in our apps. For example, the start text. So if I tap on the start text, how do I know that the start text is not intractable? Well, nothing happens. But we do have this subtle little hint with this touch visual. And it's very subtle, but these small details really matter. They make a huge difference. So if I didn't have that visual, I would be giving my machine whiplash like Kai did, because I'd be just pushing harder. How do I know that start is not intractable? But this little touch visual just gives me a hint that, sure, I heard your touch. You touched there. Great. Nothing happens. I just told you that. So, right? Very simple. So that's just a normal tap visual. And there's another nice little detail about that. So again here, I'm on the panable list. So that's great feedback that the system is listening. But on the left here, there's all this extra space. What happens if I drag there? Well, that's not the list, so it's not going to pan. But I actually get this trail. I don't know if you guys can you guys see that? It's pretty subtle. You should try it on your machines. Can you see it? Let's try it in another app, actually.
So we should say something about why it is this subtle, right? Because we actually took a lot of effort. We put a lot of craftsmanship in tweaking exactly how subtle these were.
Yep.
Initially, they were kind of strong visuals because we wanted to make sure that everybody noticed them. But we decided actually that it was more important to make them subtle so that maybe they're not always noticed, but they're never in the way.
Yeah.
And what was interesting, what we learned then is that even though they're subtle, you will always still notice them, but maybe you're not even aware of that you're noticing them.
Exactly. So I think this is going to work better on the projector because it's not black. So if I drag around here, again, I pan, but dragging above it doesn't do anything because there's nothing scrollable there. Well, how do I know that it doesn't do anything? Well, I get this little touch visual trail here, so you can see that, right? So it's a very subtle thing, but by seeing that trail, I know, okay, I try to drag, the system heard me, there's just nothing to drag there. Same thing, like I try to drag on the schedule text, that doesn't do anything, but we're being polite, we're giving you the feedback. So let's go back. So just a few quick things. So we showed you how you can improve the user confidence by making sure you have visual feedback and avoiding whiplash. And there's two things here. Make sure that your controls have the right feedback immediately as you touch down. And again, use our controls. You get it for free. And then the system will do that extra little circle and the trail. That's for free. That just happens. That's at the system level. And then if you do make your own controls or interactive elements, make sure that you do provide feedback immediately on touchdown.
So this is the last thing that we want to talk about with regard to the touch language, which is the question that whenever I say I work on touch, the first question people ask me is, how big should the objects be that I make? How big should the touch targets be? Well, we did a lot of research into that, which was a lot about people touching little squares on the screen and seeing how many errors they would make. But to make a long story short, we got a very good idea of what the error rates are for different sizes of touch targets. And what we learned from that is that we don't recommend just a single touch target. But what it depends on is, what do you want your error rate to be? So our general recommended touch target size is 9 millimeters. And that will, if you will use that size, users will make about one mistake in every 100 taps, which is pretty acceptable. But if it's something like the start menu, where it's not okay that every 100 times you try to launch an app, you launch the wrong app, or you accidentally launch an app, then you make your touch target size bigger. And then we recommend at least 11 millimeters. And then the error rate will go down to 1,000. So only 1 in every 1,000 taps will be wrong. If you want to have smaller items, so you don't want to have these huge honking touch targets, you can go smaller, but your error rate will go up. But for instance, in the case of a series of radio buttons, that doesn't really matter very much, because if I tap on the wrong radio button, I can just tap again to correct it. Nothing bad happens. So in that case, we recommend a target size of 7 millimeters. Now, one thing that's important to note here, there's the actual error rate, but there's also the confidence that people have when they're touching. And the thing that influences confidence is to add a little bit of padding. So we recommend to add 2 millimeters of padding between the touch targets.
Great.
Now let's skip because we're almost out of time.
So you do it quickly.
Well, so one thing that's important is to notice how the visual environment also influences how users think about the system. Like we talked about, what we learned at Surface, that if you show a system that looks like a mouse system, people will think like a mouse. So what our Metro style design does, it looks very different. It doesn't have windows, it doesn't have icons, but tiles. The menus are hidden, they only come up when you need them. And it doesn't have a pointer as long as you're using touch. So we found that that is enough to show to users that this is a different way of interacting with the system.
So you might be wondering, sure, this is great. I'll build a touch-first app, and that's what we want you to do. Well, what about these other input methods? So it's actually pretty straightforward. Start by making a touch-first app. So you code for touch, and because of the way the input stack works, mouse will just work for free. So that's the basics of it. But then if you use our controls actually have built-in behavior that's optimal for both touch and for mouse. And I'll show that quickly. And finally, you do have the possibility to detect where the input is coming from, so you could create value-added experiences for specific input devices. So just super quick demo of how we do that. So for touch, a great way of scrolling is by panning. But for mouse, the touch language, or the mouse language, is to use a scroll bar. So as soon as I move my cursor, I get a scroll bar. And I can really easily scroll around. I can really easily click to jump. And similarly, with touch, we have swipe to select, and that shows commands. So how do you show commands with mouse? Well, you right-click. So if I right-click, it's selected, and I see the commands. And this works the same way in apps. So if I go back to my news app here, if I want to select 3 things and watch them together, I just right-click, 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 and I can select multiple items and then quickly go back here to create a magazine. So what's great here is that the app bar is at the bottom of the screen, so it's really easy to throw my mouse cursor in the corner. And the targets are also bigger, so it makes it really easy to hit them with mouse.
So to conclude our talk, this is what we did to create the touch language, but now it's your turn. And we show to you that you can build a great app by using the touch language. And if you do that, then it will make your app more intuitive and more enjoyable to use for users. Because think about it, every user has to go through the start menu to get to your app. And if they know how to use the touch interactions in the start menu, they will also know how to use the touch interactions in your app. And finally, we showed that the controls make it easy to implement the touch language. And if you want to learn more about it, we have a few talks that we recommend. One of them is the one that is right after us in this room by Paul Gasmarino. So we're out of time, but we'd be very happy to answer your questions. We'll be in the demo booth downstairs, so please come and find us if you have any questions. Thank you.
Thank you.